Good evening, Chris Brock here with ChatGPT for Business and Life. We have a lot of special things going on right now with our community, our ecosystem. We've just launched the AI Online Classroom /TV, which is an aggregation of 6,000 videos around AI. Whatever you're looking to learn about AI, hopefully you can come here and find this to be a great resource. With that too, one of our great sponsors, CustomGPT.ai. It enables you to train, build, and launch a chatbot designed on your objective and for your business based upon the instructions and training data you set up for your business. Easy, simple, and a great platform to get going on AI for your business. Tonight, we have a very special guest. Our guest, John T Foxworthy. He's a powerhouse and a titan in this AI data science space. With 2 decades of reshaping industries under his belt, John merges the hustle of Gary Vee with the strategic depth of McKinsey, driving transformation in finance, tech, and retail. Armed with a master's from Northwestern University, ranking in the top 5 percentile, John's expertise spans AI, deep learning, and beyond. He really knows this stuff in and out. He's a practitioner and a visionary, but he's crafted his journey as a data scientist to bring it to regular people. Though he's at the helm of education at UC San Diego and Caltech and is a pivotal figure at the Global Institute of Data Science, which he founded to democratize AI. He's making cutting edge knowledge accessible to us all. His mission to empower, educate, and elevate professionals into the AI-driven future, breaking down barriers to entry and fostering a community where technology meets practicality. Tonight, we're going to dive into the essence of AI. We're going to look at strategies and quick wins. We're going to talk about how with a little grit and a little strategy, you'll be able to apply AI in your business. So with that, we will welcome John to the show.
Hello, everybody. Hello, Chris.
Hey, John, thank you so much for joining us. You have a very detailed background. I probably slaughtered it a little bit, but what I would like to do is really share with everybody a little bit about your background. That way they really get an understanding of your expertise in the field.
Yeah, I originally got motivated by artificial intelligence by a movie by Steven Spielberg in 2001 called Artificial Intelligence. And I thought at that time AI was just going to go bananas. But then I got to realize it wasn't going to happen. And then I got into forecasting. So I studied statistics. I was a staff statistician, a staff econometrician. I forecasted whether people would buy products or not buy products and why. I did that with also financial variables, the stock market, currencies, etc. I also did it with small manufacturers about their suppliers. It was something that I worked for 20 years ago. And at that time, the word data science was not really popular. There were different labels. And that's really why I'm trying to kind of create this organization, the Global Institute of Data Science, GIDS.co, because there's a lot of differences. There's change in the history. There's a bunch of labels that have changed over the time, but there's a common theme and there's a common story that can be shared with data science, machine learning, and artificial intelligence.
So that's very cool. So you were very early on in this idea of AI. AI, I mean, like you weren't very early on. I mean, it's really started a long time ago, like probably like in the 50s at Dartmouth. But let's fast forward to what everyone's talking about. Generative AI hit essentially in 2017. So you sort of saw the research papers and things like that around these transformer models. Now it's here. What do you see being the opportunity if you're not a data scientist at your daily job? What does it mean now?
Yeah, it's generative AI is a very powerful concept. It's been misunderstood for decades. It originally came out in 1988 with some Yale professors in the Department of Computer Science with a paper called Learning with Hints. And the objective was basically take existing real data and create an additional form of it, not to copy and paste it, not to fake it, but basically have its same statistical properties It's relationships between one variable to the next, one column in Excel, for example, to the next, uh, and be able to help you understand a particular environment. And there's plenty of applications with generative AI. It's overwhelming.
Yeah, absolutely. So now, like, I mean, you've educated people. So what does that mean to be like a master AI instructor?
Well, there's two things. There's one is where people who know nothing about it. That's pretty easy. It's like a bucket. You just fill things into it, and it's a great journey. And then there's people where they have stuff in their bucket, and it's kind of like, okay, we got to move this out. We got to move that in here. It's like surgery. It's a bit difficult because data science, machine learning, and artificial intelligence is basically statistics. It's not engineering. And as a result, a lot of people don't have that type of education. Some of them might have a quantitative background or not, but regardless, they really don't have that education. It's not really their fault. The university doesn't provide that resource. So that's why I created the Global Institute of Data Science for people, for working professionals, to kind of get them to upskill into AI, which is drastically needed this year in particular.
Yeah, so that's great. Like I love that transition. So I've definitely been in some really great institutions over the last year, have really got technical. I know that's not for the normal everyday user of AI.
Yes.
Like so your institute's really designed to uh, leave behind some of that academic jargon and
Yes.
really go after the heart of how do you use AI today in a way that's like effective and efficient for your use case, your business.
Yeah, I'll do the definitions if we're on a freeway in Los Angeles, which is a very difficult place to drive. The elevator pitch. Let me put it this way. So, artificial intelligence is anything that's not biological that behaves biologically. So, what that means is that your biology is defined through your behavior, and your behavior is defined through your set of actions. So, for example, if you work at a company that has a sales team, let's say 10 people, and they've been there for a long time, they have some conceptual idea, not a quantitative idea, but they can guess what the volume of sales will be next quarter or next year. So that's human intelligence. So that's
Mhm.
biological intelligence. And all the things the salespeople do, all those actions they do on their desks together in meetings and conferences, that rolls up into behavior, and that behavior becomes human intelligence. That's biological. What artificial intelligence does, it replicates that. It doesn't copy it. It doesn't paste, copy or paste it. It basically takes the statistical properties of that and then generates a forecast for the sales volume next quarter or next year. So it's basically kind of like a partner, something an augmented form of forecasting that helps. The next idea is probably machine learning. Very quick, very simple. Every time you see the word machine learning, deep learning, reinforcement learning, replace the word learning with the word estimation. It'll make your life much easier because the word learning, that's ways explained by statisticians, is that machine learning came from statistical learning theory. And the idea is like when you go to school, like in high school or in college, what happens is you get a grade, and that grade is the quality of your work. So what happens is that in your first couple of years or first couple of semesters, you decide how well you're going to work, how are you able to work to get that particular grade. And each grade is basically a forecast of whether or not you're going to get that diploma from high school or college. So that's called cognitive learning. So statisticians take that concept and they go, okay, let's do learning in different ways, but for a machine. In that case, that's why they came up with the word machine learning. So the word machine refers to a software program. The word learning refers to an estimation. So the word machine learning means, very simply, a software program that estimates. So that's very, kind of a very quick way to define certain things that are easy to use for practitioners wherever you are in your career.
That's great. So estimates are a great thing. So a generative AI in theory is able to allow us to make estimations quicker, or it's even estimating a little bit off of the prompt that we're giving it to
Yes.
sort of continue on forward. So there's this really cool idea of probabilities, and there's this whole science behind it. But what's
Yes.
really remarkable now is that you don't really need the entire science now. Like you don't really need to know the theory. to understand like what does it mean to set an objective with generative AI. You know, you don't have to really think about like
Oh,
now let's go to the drawing board and start this calculus.
yeah,
Right.
a lot of people who are not technical are not aware of this opportunity that exists within artificial intelligence with generative AI. I was really motivated in 2016, reading a book in 2014 on deep learning about generative AI because I had a problem with trying to address my corporate clients at the time when I had a company where what would happen in a different phase of the business. For example, let's say there's an oil gas pipeline where they have sensory data with small little drips, but it doesn't cause an emergency breakdown where all the workers have to run from the factory plant. So they just make sure there's no issues with that at all. So the next, the people who own the plant go, okay, we can't simulate an emergency breakdown. We can't. We can try to have people figure out ways who could run away from it. Yeah, but we can't get the pipes to actually stop. You know, and that's a huge problem that exists. So what generative AI does is, okay, I'll take the existing real data, which is observed, which anybody who looks at this data can agree, yes, that is the correct data. And that data in particular can help you to be from the statistical properties to generate an additional phase, hence generate, where you have an emergency breakdown. And that's really the idea. There's many, many, many more applications here. You can do this with marketing campaigns. Let's say you have very quickly, you have an existing product line, and you on that you have an great marketing campaigns. It has a wonderful revenue. Everyone's happy, but then you decide to add additional features and to these products and make an additional product line. But then the problem is you can't copy and paste the marketing campaigns that are in production with the second marketing campaign. So instead, you use generative artificial intelligence to create from the existing real phased products of generative AI with the products that are already in production and the marketing that's in production, generate the additional phase by its statistical properties. It's not fake. It's based on the quantitative relationships, and then I'll help you with your new product line and its new product phase. There's a lot more here. I can go on to one industry after the next, but it's bit conceptually, it's philosophical, I would say. It starts with statistics, but it becomes philosophical in a way. And in a way, I can kind of see where somebody can just get a master's degree in generative artificial intelligence. It's just a matter of time when that actually happens. I'd have to say yes.
Sure, I definitely believe there's a whole discourse and science behind it, and probably all different types of applications on ways you could use it at that level. And even I think that going back to what you've developed, with the
Yes.
GIDS platform, you have this mission to enable people. I would essentially say, and keep humans in the loop. There's a lot of like this idea of access, democratization of AI. You also talk about inclusivity and pluralism.
Correct.
With this, like, is there what makes it different today than 10 years ago? It sounded very philosophical. Now it sounds like this is a really big thing to be a part of, that humans must stay in the loop.
Yes.
What is really this mission statement that you have behind your program here?
My mission statement with the Global Institute of Data Science is basically the Olympics of machine learning. What I mean by that is that you have a bunch of sports that are operating in different capacities, all in the same place, but are somehow organized. So for the democratization in particular is that there are actually various disciplines that can actually get into data science, machine learning, and artificial intelligence. One is, of course, is engineering, computer science. A big area is also psychology, in particular behavioral psychology with reinforcement learning, which comes from reinforcement theory, which is a very deep area within psychology. And then there's also some areas that exist within art generation, image generation, video generation, audio generation, which is a new form of art. So essentially, to make it very simple to understand, if data science is the application of statistics, Then where has been statistics at universities? Essentially, it's at every single discipline of social sciences and the sciences, sociology to chemistry, economics to physics, etc. And as a result, that's why artificial intelligence feels like it's going to take over everything. And I tell people that's because it already has been in everything for quite a while. And that's why the foundation's already been laid down. We just need to make that happen. That's all.
Sure. So to bring this to a level that I think a lot of people could follow, you have a couple different articles out there.
Yes,
One is the big five in data science, machine learning and AI. And then the other one, I actually, we'll get right into here in a second. But we have this really nice overview that you put together about like this sort of combination of
correct.
all of these sciences coming into play at this one convergence point, right? And I
Yes,
think that's generative AI. And I think what's somewhat concerning is that you see all of these big words and you may not know their background or their discourse or the science necessarily behind it. Now you're thrown all of this and it gets very confusing. At
yes.
the heart of it, I feel like I see generative AI in this, but what are we really looking at here and how can we make sense of sort of
Sure.
where we're at?
Yeah, I was trying my best to provide a picture of everything that involves within data science, the Olympics of statistics, basically. And that approach here is essentially that descriptive analytics is unsupervised learning. We use the word unsupervised because there's no target or goal or objective. It's just to describe an anomaly, such as for fraud detection, or to describe a segment in your data of customers to target a marketing campaign. And then there's also predictive analytics, which is basically forecasting. You want to forecast whether your customers will buy your product or not buy your product, or if they're going to stay on your website and not stay on your website. That's a particular area. Or if you want to forecast sales volume, which is a number for next quarter or next year, like I mentioned earlier. However, there is some interaction between descriptive analytics and predictive analytics. For example, you have the yellow area and you have the blue area for predictive analytics. Then you have the green, which is overlapping. If you're able to describe a customer segment that is willing to pay more for your product, let's say, through your group segmentation algorithm within unsupervised learning. The next step would be whether or not they'd actually buy your product or not. So that's what the green area does. And that's where the overlap is. Think of it as a Venn diagram that exists. After that, then you can get into the purple areas, such as reinforcement learning. So once you actually are able to predict that this particular segment, which you've identified through descriptive analytics, and then forecast they can buy the product within the green area, then the next step would be to recommend something. Because once you predict something, you want to focus on recommendations in order to maximize your revenue. So that's where the purple areas become. In addition, there's also the natural language processing, which is would be great for sentiment analysis. You need to, from the beginning, with descriptive analytics, predictive analytics, and also reinforcement learning, which creates recommendation engines. You want to be able to see the sentiment analysis. What is the emotion that our people are expressing on Twitter X, on Reddit, on customer forums that provides whether they like your product, don't like your product, like it, but they want to have an additional feature, etc. After that, there's also an area that's a little less known. It's called graph data science, which is something that focuses on unstructured data sets such as websites, user log files, documents that allows people to process non-traditional types of data sets, flatten them, and be able to use all within descriptive analytics, predictive analytics, reinforcement learning, and natural language processing. So there is a logic within this entire framework that exists. And the simplest way to describe it is through my 5 concepts that I've developed also with another Substack, which is
Cool.
that describe, predict, optimize, recommend, and generate.
Oh, I think we'll jump right into that, but that's exactly what I was thinking. Like just this model a lot. Like, I mean, you're taking some really complex science, like to say AI, like to take science out of AI, it's very difficult. It's like a very scientific
Yes,
thing that it's getting easier and it's starting to look like magic, to
it
people.
does.
But
It does.
and which is awesome. That's sort of the goal. Like if you can make it that magical experience. But this is really what it's based off of. And I love the idea that natural language processing means that we can now program in English or your native language. And it's amazing. It's almost mind blowing. I've been coding for a long time, and to be able to fix code or just put in an English sentence and get back an output that I was hoping for, amazing. You know, the graph data science, I think what's amazing is that the large language models have sort of come in and like provided that, right?
Yes.
And if we're really good at describing what we are trying to do, like prompting, they sort of call that prompt engineering. If you have a really good prompt engineering capability and describe what you're trying to do, the better you're at doing that, you can make predictive strategies or predictive analysis. And then if you're good at training your data set, and you can use some of this like RAG models or other models to sort of train your data, and reinforcement learning is maybe a little higher level than most people are going to get into,
It
but just
is.
like,
It is. It's a hard one. It's very something, people often wonder, there's this common question within the financial community: what is the competitor of Netflix, for example, which is basically a huge set of recommendation engines. And there
right,
really isn't in one. I mean, there's a lot of intelligent people out there. I don't even say they're more intelligent than me. Maybe they have more degrees than me, whatever, but they're not able to understand how Netflix is so popular. And it's a very interesting concept, because what happens is that when you go into descriptive analytics or predictive analytics, you're obsessed with a model, and a model is a representation of reality. The problem is it could be a representation of your reality, not other people's reality. And
right,
as a result, you have a bias, which is a preconceived notion. You're like, okay, I know what the result is. I'll just find the model that gives me that result, and I'm good. I'm good then. What recommendation engine does says, forget about the model. It doesn't exist. Instead, we do a model-free, assumption-free approach, where we give recommendations over time, and as it goes through a series of experiments, it gets better and better. That's what Netflix does. If you've never used Netflix ever, and you log in for the very first time, it's going to make assumptions about your zip code, where you live, what the average income is within your area, et cetera, et
sure,
cetera. It may not be perfect, but it's going to have recommendations will you pay attention to. And from that, you start going, okay, I don't want this, I want this, I want that. It's keeping a track, like a tape recorder, of all your actions. And it shows what you're watching, what you're not watching. If you watch it in full, if you watch it partially, there's a whole more metrics involved here. And essentially, it's an experiment, because that's what data science is. It's about experimentation and understanding what your customer is, because Netflix doesn't really have any direct competitors. And the smartest people in the world haven't figured out why its recommendation engines are simply just better than everyone else's. Everyone else is about trying to predict something. And the problem with prediction, you have to figure out, well, I have perfect knowledge. I have all the data that I want. And from this data, I'm going to get the right answer. And therefore, I'm going to get revenue, and I'm going to make everything work.
right.
Not all the time. Not
It's tricky. Like my background does in programmatic advertising and omni-channel media management. So we got data from like sort of the ad tech space, so social and search engines. And they started buying data like data brokers. And they had a very distinct objective of like serving ads, so they had like, I think, a different approach. I really like what you're saying about Netflix. Like theirs is a little bit different, of like an intrinsic, you're already in their environment, you're already paying to be there, so why should I stay, so that's a very interesting thing. I've thought about Netflix, obviously, but I haven't really thought about sort of the AI mechanics that are in the background.
Yeah, it's very difficult. A good example is what I did this at a particular university, at both at UC San Diego and Caltech. I've got a classroom of undergraduates. I tell them very simply, I'm thinking of a number between 0 and 100. If you double that number, it's below 100. What is that number? So I asked the first person in the first row. Now, the correct answer is 1. So 1 times 1 equals 1. It's kind of a trick question. The first one, first guy will say 7, and
Sure.
no, that's not correct. Or can I pick someone else on the other side of the room? What do you think? And they're like 8 and 6 and 5. And they're all guessing. And here's the point about what that is. They don't have a model in their head at all. They don't have any assumptions in their head. What's happening is that I'm interfering with their process and telling them what's right and what's wrong. And eventually, over time, we get understanding about what a recommendation is. And that's what a recommendation engine is, and that's what reinforcement learning is. It's human guessing, and Netflix has way ahead of everyone else with this one.
Yeah.
Way ahead. I mean, Amazon's also very good. There's some other companies like Home Depot. I'm sure there's some other retail big box retailers are also very good with this. There's
Yeah.
actually a number of firms, but companies involved. But it is a very powerful technique because it does one thing that's very important, and that is it maximizes revenue.
Absolutely. So, and I definitely like that. And I guess like, would you consider Scale.ai in that realm of reinforcement learning on the foundational model side? Are you aware of their business?
I'm not aware of their business per se, but I wouldn't be surprised that they're using recommendation engines. It is a bit, there are companies out there that are not mentioning what they're doing.
Right. Yeah. Like
Uh,
they have
I'll leave it at that.
they have people training the AI models. They started early on, I think, with autonomous vehicles, and they've moved on to training like the OpenAI inputs. So just sort of an interesting company there. But one thing that you mentioned, and I think that this is what we should talk about now, is like let's bring this down to the people. We've talked about like this crazy, like even pretty deep talk about like computer science. This five key approaches to AI. This does not seem like I need any sort of master's degree in computer
No,
science to even follow along. What is this?
no. So basically, I grabbed the 5 major methods within artificial intelligence. It's not 100% of everything, but it's a good 90 to 95%. And that is to describe, predict, optimize, recommend, or generate. That is really the cups of it. If you can understand this very well, for example, if you want to describe an anomaly, which is an outlier, such as to detect fraud, such as at a credit card company, or if you want to describe a customer segment, a group segmentation algorithm, which would be allowed for marketing campaign to maximize revenue a little bit more. And then, of course, there's prediction. You want to predict sales volume. You want to predict whether a customer will buy your product or not. You want to predict a manufacturing process, whether you're able to fill the capacity to produce the product. Of course, there's also optimize. There's many things you want to optimize. I'm sure a lot of your audience would know what they'd like to optimize within their business. Recommendation engines, which we mentioned earlier. And of course, the holy grail really is to generate. It's to actually create an additional phase based on a current real world data of, let's say, an additional marketing campaign, or in the case for risk management, like I mentioned earlier with the oil and gas pipeline company for emergency shutdown. So that's a very whirlwind tour within data science. I can tell you this: a bachelor's degree in data science has less math than a bachelor's degree in mathematics. A a bachelor's degree in data science has less software coding, computer programming than a degree in computer science. Unfortunately, there's a lot of industry bias and people trying to protect their jobs of kind of overcomplicating things when they're actually quite simple. What is really required is first and second courses in calculus, 2 courses in calculus, 1 course in linear algebra, 2 courses in probability and statistics, and that's it. And to kind of get this message through to everybody here, if you took calculus in university for your bachelor's degree, that doesn't mean you're majoring in math. It just it doesn't, it's just like if I took a course in English literature, that doesn't mean I'm majoring in English. So let's kind of understand the level of proportion and scale that exists. What's actually much more important for people is to understand the story. Storytelling is very powerful and very important. It exists in classical statistics. So if you look at classical statistical textbooks that exist for bachelor's and master's degree, there's a lot of writing. It's, that might come with like maybe an algebraic equation, and then there's 4 pages of literature, and then there's half a page of math, and then there's 16 pages of literature. So it's a little bit of everything. Like I mentioned earlier, it's the Olympics of data science.
Yeah, absolutely. So, with that, do you think where generative AI is at today, if I go into
Ah,
ChatGPT, maybe I call a Python call to do some type of calculus or math,
mhm.
do you trust generative AI to do anything like that at this point
Ah,
if you add some variables to it, or is it
wonderful
too early?
question. Wonderful question. Whenever something is generated, it's created, or it's innovated, you then have to test if it actually makes any sense. There is a problem that largely exists within generative AI, and that is something called a bias. Your expectations are so high, you're kind of a little too excited. Okay, I'm using this; it's going to work. I know what the answer is. That's really confirmation bias. And then also there's another bias called anchoring bias that exists within data science, which is whatever the first answer is, I'm done. It's good. We're ready to ship it. Um, I really ask a lot of people to kind of calm down and kind of think it through a little bit before you kind of pull the lever to production. Does it actually make any sense? One way to actually do this is to go to the business people and see this additional phase, which is theoretical in its sense. Does this actually make any sense? And I can tell you from my instructions from universities and also my consulting business for quite a number of years, they'll tell you whether or not something will happen or not, because that's what they do. They're like, well, I don't think that's going to happen because for these following reasons, or yeah, it's possible. It's very rare, but it's possible. So they'll give you that answer. The thing about generative AI is that once it was created, I mean, the most important work was created 10 years ago, 2014, with generative adversarial networks, GAN. That was a very important hallmark that existed in generative AI. And it's already been automated in a lot of automated auto ML software programs. But actually, interpreting the results can be difficult. It's actually more difficult than the math and the coding. It's kind of philosophical. I'm pushing it when I say philosophical, but it's close. And a lot of people who've been in this business for quite a while would know that. We need a good product manager. You need a good data governance manager. You need good C-level executives who have in-depth experience and intuition about this area, who can actually give you a good opinion. I'm like, well, that scenario seems pretty plausible. So that's where generative AI kind of exists. I think that it's going to grow quite largely. However, the interpretation is where people will make money. Uh,
Sure.
that
Well,
is for sure.
I've seen that like last year, I think everybody was just surprised that generative AI happened. That really put it on the map. Like, I mean, before last year, I'm a coder. I was using different platforms and always using APIs and things. It wasn't really until ChatGPT 3 launched that it gave everybody an interface that was open like a browser interface, but absolutely interacted a lot differently than a traditional browser that like opened up, this shock and awe period of AI sort of is here now and it's going to like go ubiquitous and go amongst everybody. Now, over the last year, I think like 2023, people were sort of still shocked and they were getting on the hype train. So we have this hype train definitely going into 2024.
Indeed.
2024, I'm seeing all these businesses that are like, okay, I know hallucinations or confabulations are existing and it's going to sound confident, so I don't want to do anything wrong. I've heard these legal battles that people have cited wrong cases. I've heard businesses
Yeah.
like, use a chat bot and it provides like people free tickets and we're not supposed to do that. So there's been some failures. So I've seen everybody at this point build committees, right, for governance. So
Yes.
my long question would be, what's your recommendation to companies that are now putting a governance policy in place to
Oh,
figure out how to even attack AI for their business?
yeah. You got an hour? Let's talk about this. Okay. So data governance is basically the the policy that evaluates its people and policies for an organization to maximize and to protect the data assets of an organization. That is to make sure your data is clean from HR to accounting to engineering to marketing and sales. Governance is a very top-down method of a word. So it's basically everything within the organization, not a single department or a set of departments. So data governance in particular is extremely important. It is the fundamental reasons why certain companies will fail and not fail and succeed, or even partially succeed with artificial intelligence. The companies that actually have a formal data governance policy will be the first to implement a machine learning algorithm or an AI algorithm. And I'm saying this, period, full stop, nothing else to discuss. You cannot get into artificial intelligence and machine learning without any clean data. If you're doing Formula One racing, you need to make sure that your car is in perfect shape and you have gas in it. Otherwise, you're not getting anywhere. And that requires to have a formal enterprise-wide data governance policy plan run by a director of data governance. And more importantly, it would be great to have a chief data officer who create the data strategy for the overall enterprise. Then below that, you have a director of data governance who can manage the quality, the priority, go from marketing to sales to engineering to accounting, etc., to manage the entire process. And I'd have to say, a lot of people feel that artificial intelligence is going to kill jobs. I'm like, no, the lack of data governance policies will kill people's jobs. They will be outcompeted with another organization who already has that, and they're able to maximize their revenue, minimize their cost, outcompete you, and move forward. And because you're not ready, and if your historical transactions such as sales is not clean, you're in a lot of trouble. Uh, you're you're in a bad place. I would suggest you leave the organization and apply a job for somewhere else, because if you don't have hold of your data, I mean, if you don't have hold of your inputs for the machine learning algorithm, you're in a world of pain. That is, it's just not going to work.
Well, that's what I think is really interesting about a lot of companies are on legacy systems, right?
Yes.
And they sort of hobbled together their cybersecurity policy and their CRM and their ERP system and maybe their marketing automation system and social media and all this stuff's coming in, and now they have this AI component. Do you see that AI will actually help some of these CTOs with the decision making, or with the maybe even the coding strategies on how to not only leverage AI, but maybe even how to connect it, right?
Yeah. Yeah, I got some things to say about that. So the primary objective and focus of a chief technology officer is the technology stack. The primary objective and what to focus on of a chief data officer is the data strategy. They're somewhat related, but they're also quite separate. The chief technology officer is not the chief artificial intelligence officer. It just doesn't really work that way. For people who are listening here, you can go onto Netflix, on YouTube, for example, and listen to the chief technology officer at Netflix. She has a PhD in economics from Stanford. She she doesn't really have a software development background. So if you actually think about what is the background of chief technology officers at these major firms, you would be surprised at how it's not really software development focused. And that's largely because data and technology can be separated. And the way I would kind of put this in a very simple sense is that, all data is technology, but not all technology is data. And once you understand that kind of Venn diagram that exists between the two, the parts of the chief technology officer, which are not about data, then you can see why the CTO is not really responsible for this area. I do understand that, according to surveys, that a lot of companies are looking at the CTO to come up with AI and ML types of practices, but it's not their wheelhouse. It's the same thing with data science. It's not engineering, it's statistics. There's a department of statistics, there's a department of engineering, they're separate. It's like the same thing. Let me give you a quick little analogy.
Sure.
There's a couple of journalists in the New York Times who can give you a fantastic option and advice about what novels to read. And the first question I would ask is, did that journalist write a novel? Some of them have, but a lot of them have not. So what we're doing is we're taking two different professions, and because they use the same resource, we're confusing the two. The reason why we know journalists are not novelists, because we know what a journalist does, and we know what a novelist does. But a novelist reads English literature as a resource to make more novels, whereas a journalist reads English literature, including novels, not to produce a novel, but just to be a better writer in terms of shorter content and have a style that pays, their profession. By way of analogy, this is the same thing between computer science and data science. Computer scientists will use the Python programming language, for example, for doing something like creating a user interface, creating data pipelines, which has nothing to do with machine learning. But at the same time, a data scientist will also use the Python programming language, but for a completely different objectives. So naturally, you're confusing these two different professions simply because they're using the same profession. Once you understand this distinction, I basically tell people, if you want to get started, if you want to walk before you run or crawl before you run, hire a bachelor's degree in statistics, not a master's degree in computer science or something like that. They simply would actually know the exact equations that go into machine learning, because machine learning comes from statistical learning theory. And
Sure.
you don't learn that in computer science department. I mean, Stanford University, wonderful computer science department, outstanding, superior, great, yes. But they're the exception to the rule. You can't just take that university and go, oh, yeah, it's like the University of Idaho or the University of Texas. No, 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 no. It's not the same thing. There's a lot of diversity here, really. But if you hire somebody with a bachelor's degree in statistics from any university, they actually can segue into data science fast, quick, because that they already know what the equation is.
Well, I love what you're saying here. So like what I think it really boils down to, even for other people, I think that AI is like a great enhancer. So if you were a C+ student in statistics,
Yes.
AI might be that way that you can go from like sort of mediocre at stats to pretty good at stats by leveraging computer systems. If you're really good at describing your problem and figuring out the calculus or what your KPIs, your key performance indicators are, you
Hmm.
can probably model some predictive results in a
Correct.
way that before you would need some specific systems that were not necessarily like unobtainable, but maybe outside of your team. Maybe if you're using like BI, like from Microsoft, or you're using Tableau, maybe you have a little bit of some data that you're trying to visualize and build, a little bit of like a business model.
Yes.
But now it's so much more open to be able to at least build that basic framework for the statistics behind your business. I think very heavily, like on the idea of game theory too, that if you could gamify your business and like you just think of it just like Mario Brothers, you're just trying to get coins for your business, you're just trying to grow and get through the
Oh,
boards and things like that. If you could build a game around your business, but instead of getting coins, you're getting these like KPIs, revenues, or new clients or new leads. There's ways that you can map out your business. And if you're very good at describing that to the AI, and it's not just one shot typically, um, post prompt, and you're going to get all of this. But if you have a little bit of chain of thinking prompting, you can probably, with just a large language model, get to a place where before you would need a high level consultant that maybe has a statistics background or has an MBA and like a whole team of tactical innovation management teams coming into your business. Now I think it's empowering the C-suite. If you're already a producer, you can really produce by describing your problem and trying to predict from that. And statistics, there's a long history of it. So I'm right with you. If you understand some statistical logic, all the better, right?
yeah. I would say there's two problems with classical statistical training. One is the professors themselves. Just like acting, and professional sports. Um, the professor salaries are too low for the real world. If you have a PhD in statistics and you're teaching in university, you can be paid more elsewhere. The same thing. I mean, if you think about if Robert De Niro or Meryl Streep wanted to teach you acting, imagine how much you have to charge them an hour. Or if your kid wants to be a quarterback at high school, how much would you pay Tom Brady per hour to teach your kid? That's going to be a big number. I don't know what it is, but it's going to be a big one. So it's the same thing with statisticians. For decades, they have every financial incentive not to teach. So what you're left with is a bunch of professors who are not necessarily the highest quality. The other problem is that students have a bias against statistics in particular because it has to deal with uncertainty. It has to do with like reading some math, understanding what you're seeing, and then writing extensively about it, about uncertainty. And uncertainty is not really something that's interesting at 19 or 20 years old. It's going to really turn you off. You'd rather go to engineering, like, well, x equals 4. Okay, I'm done. I'm going to just go home. Whereas, statistics will go x equals 4, but let me write half a page. that that is that's just not really common. And our educational system is not really doing a good job with training people with statistics, whether it's econometrics. Clinical psychology is also a very deep background within statistics as well. Operations research in particular is also, that's basically just manufacturing optimization algorithms for your manufacturing processes. And also just classical statistics, which can be applied in every single social discipline, every social science discipline, and also every hard science. And I can tell you, I've talked to people in physics and geology, at Caltech, at UC San Diego, and they don't like the uncertainty. Nobody
Sure.
does. But that's where AI is really going to take over, because people have this mindset that they're kind of like, this can't work. This is not going to work. What are you talking about? How can you actually have a series of errors, then after a while improve it and have a perfect product? What are you talking about? That doesn't make any sense.
It's definitely a phenomenal step in human innovation. I think we're definitely living in it right now, that we have this almost like it's definitely not consciousness by any means, but by having this probability based platform.
Yes.
World models that, and it can take our thinking and sort of expand it, and based upon probabilities in a very real way, it can assist us in telling that, like further developing that thought, as if we have John right on our side with the statistical background to say, you know what, you should do this here. The AI now, if you can describe your issues, can sort of point you in that right direction in a way that drastically will improve, I think, our ability to launch statistical
Yes.
analysis in our organizations. But it's also a big gap, because I think it's always been something that people feared. People feared doing math, or I'm not good at it, so they ran away. What do you say to people like that have had a fear of math?
In terms of the fear of math, I think it's really a matter of like, what is the resource of where you're getting your education in particular, and who is the interpreter of your education in particular, and how that actually helps. Because your instructor is a major point in terms of where you get your mathematics and statistics. Some schools are very good at it, some ones are not. But I'd really kind of focus on your source of your education. There's also some books I can kind of point out in terms of where that will be helpful in terms of understanding statistics properly. And there's also some decent YouTube channels out there that do a good job with statistics in particular.
That I definitely agree. And with that, we're wrapping up like our hour. But I think it'd be really important to share with everybody a little bit more specifically about how they can get involved with what you're doing, and maybe define a little bit more again from what we covered really in that sort of beginning setup of what is this AI incubator? What is this Global Institute for Data Science? And why people should really follow what you're doing out there.
Sure. The Global Institute of Data Science provides two major services. The first one is individual accelerator, and the other one is corporate team training. So the AI incubator that you see earlier is a corporate team training. So what that means is that I provide training to accounting, engineering, marketing, and sales to get them to work together to produce an AI product, and actually also produce a data governance policy plan for your organization for data cleanliness, data priorities, and a data strategy in particular. So that's what the AI incubator is, which is corporate team training. In addition, I also do keynote speeches to people. If you want me to do a particular subject for absolute beginners of AI and machine learning, or if you've actually already put a machine learning algorithm and you want to go into an additional area within machine learning, I do that as well. Separate from the keynote area and for the AI incubator, I have the learngids.com, and that learngids.com provides individual AI accelerators for working professionals. So I basically teach you everything about artificial intelligence, which is describe, predict, optimize, recommend, and then generate, which is unsupervised learning, supervised learning, reinforcement learning, natural language processing, and deep learning. You do not need to code. There's a lot of areas that exist within a large language models to generate the code for you. And also a lot of these models are actually quite old. For example, the most commonly used model for consumer economics is random forest. It was created 30 years ago. It's already been automated. You don't need to code for that at all. So I provide individual services, corporate team services, and then also the keynote speaker that exists on my website, which is gids.co.
Well, that is awesome, John. Thank you for sharing that. I hope we can continue our work together on your platform.
Yes.
As I believe that there's some really cool things that we definitely didn't cover tonight. There is a little bit of storyline and some logic behind even the logo, so I'd love to dive deeper into that with you in the future.
Yeah, I'm trying to pack that. That particular logo, what that is it takes the human brain and also the neural network graph and puts them together into a global interface. So on the left, it's two blue circles, which is the entrance. And then in the middle, the inner layers of deep learning, my favorite subject. You see the yellow is red, which is attention. You see the white go through to the next. And then there's green, which is accepted, light green, partially you do it again. But there's a whole lot that I'm going to work on icons to help people get into artificial.
I think that's great. I think everybody would love to learn a little bit more about that as we're diving deeper into this technology stack, this future of AI. I think we're definitely at this cusp, at this future that's changing, this generative shift. It's time for people to sort of jump in. I do think, and you sort of covered that tonight, that if you are a business that can say yes to AI, figure out your governance and policy and say yes and start using some AI in your business, that's probably the best way. My advice is sometimes it costs a little bit of money, not a lot of money for it's what it delivers, but it's sometimes better to do some tests. That's statistics, that's science. You got to do some tests. So definitely try that out by saying yes. One thing while you're here, John, I want to show everybody what we've been working on. Okay, and this is testing as well. So what we've built this video aggregation platform. We have 6,000 videos in it. What we realized is that our training data needs to be enhanced. So we're building better training data based upon all the videos on the platform. So we feel that if we train the platform more on data, our chatbot will be smarter, right? So what this has right now, we'll see if it can work. you can even help me do this. So how will AI impact my industry? Let's use that one, and I'll let you give me an industry. The design here is to avoid a wall of text and instead try to find out a little bit more. So how to build these intentional bots. So what industry should we look at, John?
For intentional bots, probably for customer service for retail products.
Perfect.
That'd be area. You can also do this with healthcare companies who have people have questions about their insurance. There's that. Potentially very large firms with paralegals to do that.
Right. So I think we're going to move into this realm of advisory bots. And there's a whole science behind it. I'm sure you've been working on that for quite some time. But what's cool about what we've put together, no matter where you're coming from, if you're interested in retail, in CPG, or customer service, you can come to our site. You can interact with the AI, answer some questions, and it will actually provide video recommendations on what you should watch. Okay, based upon the data that we've built. So trying to match people almost in a new medium, right? Where it's video, it's dialogue, and that sort of meeting right here within the chat bot. So that's what we've been working on. I think we're starting to see some good results. I think it's going to get better over time. And by working with people like John, we will be able to provide quality content that's trained and expert driven. I hope to have John on once a month for the community just to talk about different areas that may benefit sort of maybe that C-suite or that adopter of technology. Also sort of that business or nonprofit organization or group that wants to take that step to accelerate into AI, and they know they're ready to make that first step into AI and really do it the right way with the strategy. So with that, John, I want to thank you so much for joining us tonight, sharing your expertise. Is there any other thing that you would like to share with the community before we log off?
Sure. I'm in the process of getting hired for the University of California, Los Angeles. I'm going to be rewriting the national language process curriculum, and it's available summer or fall, depending on how much they're allowed to do work and have proof. But it's something that's important for me because competition of mistakes is the future. Not just GPT, there's many other products that are available in this space. I think the world has changed dramatically in the next few years.
And with that, I totally agree. We'll sign off. Everybody at ChatGPT for Business and Life, thank you for tuning in. John, thank you again for sharing. And we'll make sure that everybody can check out GIDS.co. That's the Global Institute for Data Science. So again, thank you so much for your time. And we'll sign off from here. Thanks.